5.6, similar figures. Similar triangles. Two triangles that have the same shape are similar when their corresponding sides are proportional or have the same ratio. The two triangles I have shown you are similar. The reason why, again, is because corresponding, meaning their location of the sides, are proportional. I like to think about it as one is going to be your model and the other one is your actual in real life. So we would say that C is corresponding to F. We would say A is corresponding to D. We would say B is corresponding to E. And we could write that as fractions. We could say that A corresponds, A and D are corresponding, so we could write A over D. We could say that B and E are corresponding, so we could write B over E. And same thing with C and F. We would say that C and F are C over F. And that each of these would have the same ratio. So A over D is the same as B over E is the same as C over F. Let's look at how that applies. The two triangles are similar. Find side X. So we're always going to have a model and we're always going to have an actual. And it's really good to label your triangles because then when you label and create your fractions, you will have something that you can go off of every time. I always do my model to my actual. Doesn't matter which one is which. So we know that X is the same as 5 in similarities. And we could pick which other one we want to use, 25 or 24 or 28 or 6 or 7. I'm going to go with 24 and 6. So if we model over actual, we have our model, which is X, over our actual, which is 5, is equal to our model, which is 24, over our actual, which is 6. We're going to cross product. X times 6 is 6x. 5 times 24 is 120. Divide by 6 and you get X equals 20. The same thing would have happened if you had chosen to use the 28 and 7. So if you had used 28 and 7, you would have gotten the same answer. It doesn't matter which one you use to get your results, as long as you keep it proportional. And by proportional, you have to have your model all on the top and your actual numbers all on the bottom. Let's look at another example. Suppose the width and height of two similar drawings are proportional. Find the width W of the larger drawing. So we have our model to our actual. Again, you could have labeled this model and this actual. It doesn't matter which one you label as long as you label one of them. I'm going to write model over actual to remind myself. And then I'm going to compare them. So in the same location where 16 is on the long side is 32. So I have 16 over 32. and that is equal to the 12 over the width of the model over the width of the actual that we don't know. Now we cross product. 16 times W is 16W. 32 times 12 is going to give me 384. I'm going to divide both sides by 16. And when I do, I get W equals 24. So we could say that it's 24 in the units, centimeters, for the actual width of the drawing. Let's look at example 3. A building, and the building is kind of hard to see. There's a building here. Casts a shadow of 105 feet, while a 21-foot flagpole casts a shadow that is 15 feet. Find the height of the building. So I want to know what the height of my building is. We label each of them one model and one of them as our actual. So I know that I have my model over my actual. I'm going to start with the model. I have a height of the flagpole is 21 feet over the height of the building, which I don't know. The model has a shadow of 15 and the flagpole has a shadow of 105. I'm going to say that again. The model has the flagpole, which has a shadow of 15, and the actual, which is the building, has a shadow of 105. I'm now going to cross product. When I cross product, I do 15 times H to get 15H, and 21 times 105 to get 2,205. Want to get H by itself, so I divide by 15 on both sides. And when I do, I get H equals 147, which is feet, and that's the height of the building. Sometimes they don't give you a drawing, and you need to create it yourself. So how high is a flagpole that casts a 42-foot shadow? Okay, so how high is the flagpole? So we're going to draw our flag, and we're going to think to ourselves, how tall is that flagpole when its shadow is 42 feet? And we'll label this as our model. To the actual, okay, is the one that says at the same time a 5.5-foot woman casts a 7-foot shadow. So here's my woman, and she is 5.5 feet tall, 5.5. We're going to convert that to a decimal, 5.5, and she has 7-foot shadow. This one's my actual. So we have model over actual. We know that we have the model, which is the height of the flagpole, over the height of the person, which is 5.5. We know that the shadow of the flagpole is 42. We know that the height of the actual woman is, or the height of the shadow's length is 42 of the flagpole, and the shadow's length of the person is 7 feet. I'm going to cross product. 5.5 times 42 is going to give me 231. H times 7 is going to give me 7H. Remember, the number always goes in front of the variable. I'm going to divide by 7 on both sides. 7 divided by 7 is 1, so I get H. And 231 divided by 7 is 33. So the height of the flagpole is 33 feet. Let's do the last example. Chessboards are square regardless of their size, that makes them proportional to each other. Suppose we have a chessboard that measures 20 inches, okay? So this is our first chessboard, and it has 20 inches on its one side. And that means that the perimeter of the board is 80 inches. And that's because 20 plus 20 plus 20 plus 20, perimeter goes all the way around, is 80. Using the measurements of this board, design a life-size board for the local park. The board can accommodate a board that is a size of 240 inches long. So in our actual park, we're gonna make a real life-size one, and each size is gonna be 240 inches. We wanna know, what will the perimeter of the new board be? For perimeter only, you cannot do the same for area. You're going to write your 20 inches for your model to your perimeter. So we're going to have our 20 inches to our 80-inch board is equal to 240 inches to the perimeter we don't know. Okay, so for perimeter only, we could do this. Now I could simplify this fraction to 2 over 8, but I'm just going to leave it, and I'm going to multiply. 20 times P is 20P. 80 times 240 is going to give me 1920. I'm going to divide both sides by 20. And when I do, I'm going to get P equals 960 inches. Now, how else could I have figured that out? Well, I know that this is 240, so the perimeter would be 240 plus 240 plus 240 plus 240. So that means that I would have had the zeros all added up, which would have given me 0. 4 plus 4 is 8 plus 8 is 16, carry the 1. And 2, 4, 6, 8 plus 1 is 9. So I would have added them up and got 960 inches. You could do it this way, you could do it with a proportion, whichever way works for you. But again, this section was focusing on similar figures. So this is again 5.6, similar figures.